Hi, I'm Kirk Taylor from Custom Design Studios, and we're over here with the Orbis wheel over That's right. So, hi, I'm Kirk Taylor of Custom Design Studios, and now that we've seen the Orbis wheel over in the lab, we're coming over in the machine shop to talk with Scott about the production of the wheel. Real hands-on experience here. This is Scott.
Hi there. Okay, yeah.
We'll give it a test drive.
Yeah.
All right. Hey, I'm Kirk Taylor, and we showed you the Orbis wheel lab the other day where we looked at theory and practice with the working prototypes. Now we're taking you over to the machine shop side, the production aspect where things actually get done on these $1 million CNC turning centers. With me right now is Scott. He's in charge of this operation. Scott makes things happen here. So, Scott, what are you going to show us today?
Yeah, well, I can show you our mill here. We've got mills and lathes, CNC turning centers, CNC vertical machine centers, where we take rough, raw material and create parts out of them.
Fantastic,
So what that generally includes is a 3D model done on a computer, and then it's put into a software which basically encodes that into a program that the machine can read, and then the machine creates cut paths and actually mills out or turns up an actual part. So
it's an amazing process. You know, for me, I grew up in a machine shop, so this is really something that I enjoy because it was part of my childhood, being around the actual manufacturing of something from nothing. You know, and this is where it's taken us now, state-of-the-art, 21st century, you know, computer-controlled turning centers, making these beautiful precision machine pieces of work that end up becoming the Orbis wheel, the ring drive technology.
Right.
So, what do you say we take a trip in the back here and see what goes on?
I can show you this right here. This is a piece of raw material. This is aluminum plate that's sawed into a ring, and we're going to take that and basically put that into the turning center and create a rim out of it. So that's right over here.
Cool. All right, hey, I'm Kirk Taylor from Custom Design Studios, and we just took you over to the Orbis wheel labs where Marcus gave us demonstrations of the prototypes, the theory, everything behind the technology there. And now we're over on the machine shop side of the operation where my good friend Scott is actually making the pieces on these beautiful $1 million CNC turning centers. This is all 21st century state-of-the-art equipment here. Super high precision, super high quality. It's come a long way. You know, for me, I grew up in a machine shop in the old manual machine days. And so it's like being back home in a lot of ways. You know, I really enjoy watching something being made from nothing. To me, there's nothing more beautiful than a handmade piece of equipment that started from a blank of billet steel or aluminum. So Scott, you want to give us a little tour of the facility?
Yeah, we've got all of our machines are made in the U.S. They're all Haas machines. We've got vertical machine centers and CNC turning centers. We use the Haas because it's U.S. made. They're made right here in California. They're easy to get service on and everything. They give us options for the wheel that work really great. So we have live tooling in one of our lathes that we can actually do milling operations in the turning center as well as just turning it. So it makes turning the wheels doable in one machine. So we've got blanks here that we will put into the machine. You know, like you said, raw material, and it comes out a part. It's a little more complex than that, but you know, basically we have a 3D model that we use to generate a tool path through some software, and input that into the machine, and the machine, you know, does the majority of the work. So yeah, it's pretty impressive.
Sounds good.
Yeah.
Let's take a peek and see what's really going on.
Let's check it out.
Making these, well, they were thermal melt test kits, you know, thermal melting point or whatever.
Wow, what a trip.
I know, right? He made bootleg Quaalude presses and things too.
Oh, wow, man.
Right.
Yeah, this is great. Well, the clients for this now, they're like now that with all the legalization and stuff,
Yeah.
they're like high-end businessmen. You guys
I
walking
know,
in
yeah.
suits, walking around saying, okay, well, yeah, we'll take one of those, and
I saw a piece on MSNBC recently, and I forget the host's name, but he's a financier guy. He's kind of like one of the Shark Tank dudes,
Yeah.
right?
Uh-huh.
Anyways, he was doing some interviews up in the Emerald Triangle. Lo and behold, he comes up on Huckleberry Farms and Johnny Casale running that, and I'm like, that's Johnny Jr. That was my dad's old
oh, really?
business partner,
Oh,
drug
wow.
dealer, you know?
Uh-huh.
So the apples don't fall far from the tree.
Right, right.
Junior got into growing because they'd moved up to Honeydew after they kind of like got away from the Marin County Coke scene.
Uh-huh. Nice.
The 70s were fun,
They're
man.
different, right?
The 80s were ugly, you know? So, but yeah, so, you know, the kid grows up and now he's got a big legal
Big old
grow
farm.
up there,
Yeah, right.
you know?
Yeah, probably
Doing
making
the-
some money.
I hope so.
Yeah. Yeah.
God, now with the government stepping in like
I
this,
know.
I mean, they're just,
Yeah.
they're greedy motherfuckers.
Yeah,
you
I know. I know.
All right, so Scott, you want to give us a little rundown on what this machine can do and what makes it special?
Yeah, this is an awesome machine. We got this machine about a year and a half ago, and it was over $100,000, but it's proving to be very worth its money. So what's really special about this turning center is typically on a turning center like this, it only turns parts that are round, all parts that are round. This one is very special because it has what's called live tooling. These are little milling heads that allow us to actually mill shapes, drill and tap holes, drill off-center holes. We can even come down and we milled this keyway.
Now, is that all in one operation?
That's basically, it's probably 2 operations, but it's all on this machine.
Wow.
So this part starts off just a solid block, a solid round bar of stainless, and all of these dimensions are turned and controlled by the computer to generate this part, all on this machine. So typically it would take 2, maybe 3 machines to make this part, but we do it all on this, and I just really geek out about that because it's such a neat option that we got on this. So.
Cut.
Yeah, sorry.
So each one is so you have a special drill for each part.
Exactly, yeah. So this is an actually milling cutter. So that will spin. This can come down, and while this is spinning, this is turning like this, and it's actually creating this shape right here. And then like this reamer will come in, and it'll come in, and this will go up to the top, and this will drill and ream, drill and tap these holes, all off center, whatever needs to happen.
And this is how the Terminator started,
All right.
when the machines took over. Notice the big red button, emergency stop.
Yeah.
That's when all hell breaks loose. Hit that button.
That's right. That's right. Yeah. They're all programmed in, and 99% of the time you don't have any issues. Right? But it's that one little bad piece of code or something, and the part wants to, or the tool wants to jump into the part or go off to the side. You know,
Catastrophic.
it can be. Yeah. Luckily, we've got great programmers. Jeremy just does a killer job. He has a lot of safety lines in the program, always referring back to certain parameters he's put into the code, so that we alleviate a lot of those crashes.
Good.
We don't really deal with
Safety
those.
first.
Yeah.
Remember, kids, don't try this at home.
That's right. Yeah.
Hire a qualified professional like Scott. Remember to shut the damn door with the safety glass on it.
Right. Yeah.
So that you don't eat it.
Here, I can. Let's see. I think I can just turn the spindle on. I think. No? Am I in the wrong mode? Let's see. Yeah, I might have to have Jeremy come and.
Scott, do you find that sometimes you miss the old manual equipment?
Sometimes I do.
Yeah.
That's really what I'm most comfortable on.
Yeah. Me
You
too.
know, I have the younger guys basically running the CNCs, but the manual machines is kind of where I started. That's where they started too.
Yeah.
But it's actually really hard to find guys that started on the manual side. A lot of people just start on the computerized side, which is great, but they miss a sense of feel. You know, I know you know what I'm talking about. When you can feel the metal cutting or a tool pushing, there's that sense that it's sort of innate that you kind of grasp on manual machines. And if you don't start with that as a foundation, it's really hard. It's impossible to teach.
I think the math skills too that have gone away. You know, that's one thing I was never very good at. Like I tell people, my dad was a machinist. I'm not a machinist. I can work machines all day, manual equipment all day long. I can hold tolerance, plus nothing, -2, whatever, do production run stuff as long as you point me in the right direction. But I could never sit down there and look at a blueprint and figure out in my head and do the math and go, this is how we're going to get to Z.
Right.
You know, I don't even know how to start at A other than here's a block and what, you know.
Yeah.
But that was an amazing skill to see, you know, these old timers have, man. It's the ability, I don't know nothing about trigonometry.
Yeah.
You know, but it's kind of like, you better have that skill, otherwise you're not reading that blueprint right and something's going to go wrong. Yeah, know?
There's a couple formulas that are like hardwired into my head, you know, for finding circle dimensions and you know, angles and you kind of have to have that stuff.
Yeah.
So there's a minimum level that you
I think
have
coming
to have.
from the beginning, the basics manual and coming into the CNC world is probably a much more natural, you know, progression than to go the other way. Yeah.
Well, it's all encompassing. It's a more holistic approach.
Yeah.
So there's some issues that you might have on a CNC machine that most guys wouldn't know how to address, some chatter or a bad finish or something. But a guy that started it manually could remember, oh, you know what? I'm probably going a little fast. You got to slow it down.
Dial it back a few RPM.
Yeah, I can dial that, and luckily we can dial that stuff in. But if you don't know what to change, what parameter to change, you're kind of dead in the water. So
yeah, like I know that, you know, with stainless and most of the harder steels, you definitely run your RPM lower.
Yeah.
Aluminum, you can spin it up really high.
Crank it. Yeah.
CNCs allow you to move at a much more rapid pace.
Right.
You know, but that also smokes a lot of tooling.
It does, yeah. You make one wrong move, and the stakes are higher because your RPMs are faster, you're more rigid, so you can get a lot more done if everything's right.
Yeah.
If things aren't right, things can go really bad really quick, and it gets ugly really fast. So
kumbaya.
For sure. A lot of life lessons in machining.
Right. Well, I like the comment you made about the holistic approach.
Yeah, right.
Like, you got that? Holistics in a machine shop?
Yeah, right.
Wow. when we the yoga class? When's that start?
Yeah, that's 6:30. You missed that.
Very good. Here, let's scoot that up. You can lean in a little more if you like.
Yeah, I got that, and I got him working.
There's Warren. All right.
Hey, how's it going?
Hey. This is how you see if you're a real porn star, right? Do you measure up? All right. We got the tool to prove it. All right. Yeah, no, we got some good stuff going. Our banter back. Justin Trudeau's got eyebrows, man. He could get a righteous toupee, you know. Because I don't think the Donald Trump. I brought that other camera if you wanted to set up fixed, whatever. But
I grabbed.
Yeah. Okay, so Kirk, now we're over here at the mill. And again, a Haas machine. This is one we just picked up. This is typically about a $100,000 machine as well. Now this machine's different because this machine, you clamp the part down to the table, and the tool is held up here in this spindle, and the tool comes down and does all the milling and cutting. So
wow.
The tools are held up in this carriage up here, and it drops down.
This does a complete drop down into the work area.
Yeah,
okay.
Exactly. Yeah. So this is the kind of part, you know, this part would probably come off the lathe. This is the raw material. So
here we have a blank, and this is a finished product.
Yeah, at one time this was just a 12-foot, 20-foot long piece of round bar, sawed up, and we get that blank. we take that blank, we turn all these features in it in the one of the lathes, and then at that point we put it into the mill, and we can drill and tap these holes. We can clean out this seal area, drill and tap the holes. We can do all that here in the mill.
So in this counterbore relief, you drop a seal down inside of it, and the shaft runs through the center of it?
Exactly, yeah. And then there's another seal retainer that sits on top and holds
Keeps
that
it in
seal
place,
yeah. Everything, all, very tight tolerance, seals, bearings, fits, all that stuff, it's got to be just right on.
Yeah, and the seals have a service life,
Sure.
before they start to fail. So just by removing that cover piece, you can access it and pop it back out and drop a new one in.
Yep, exactly.
Very cool.
Yep.
Nifty stuff.
Yeah. Footage of
and remember,
doing the tool change,
the
and
emergency stop button. Kids, don't try this at home. Hire a qualified professional like Scott.
That's right.
Because if something lets loose, that's what you need to know. In the advent of an emergency, press the big red button.
Yeah, hit that.
Yeah. Right. See? Little flashing lights. What's that mean? It's universal.
That's right.
Okay, let's cut.
Oh.
So again, this is and just do whatever you want to do.
Yeah, cool. I'll just cycle down a few times and get a tool in the machine, and then it'll take.
Mr. Roboto?
Yeah.
Okay.
I got to skip ahead here a few. There we go.
There we go. Flip the indicator in.
Yeah, this is a probe, and so this probe comes down, and with the part in the machine, it'll come down, it'll probe and find the location of that part. So then it automatically inputs those location points into the program. So then the program or the machine knows where to run that program in this envelope. So then it'll come down and say, oh, okay, so here's the bore. So I can come down and I know I can drill right there. That's what this tool does.
So is that flexible like like an indicator?
Very lightly. It goes off touch. This is a ruby little element.
All right. An industrial grade ruby, yeah.
Yeah, exactly. So it comes down and probes it. It's a very light feel. It's very accurate. You can also use this to measure parts. So you can come down, touch this, and then the machine moves over. And while it's moving over, it's measuring how far that move is, and then inputting that into the system. So it's a really neat option.
Literally, yeah. And part out.
Oh, let's go the other way here.
Is that amazing?
So we're gonna go the other way. I'll put another tool in there and we'll talk about it. Yeah, so this one is just a small, I think it's a 1/4 inch end mill, and that little tool will just cut through this thing like butter. It'll open up that bore, cut squares into whatever we need to do.
What kind of RPM do you generally run with that?
Yeah, this is going to be probably in the 2,000 to 3,000 RPM range.
Okay.
This machine's really rigid, so it can handle that kind of shock. This tool cutter is actually solid carbide, and it's ground, to this, very intense, very tight tolerance geometry to enable it to cut, stainless steels, aluminum, whatever. And the coatings they've done on these are just amazing. They make the tool actually last so long. It's unreal. Compared to tools even 5-10 years ago, these are lasted 2 to 3 times longer.
Oh, great.
You pay a little bit more for them, but $50, $60, $80 little cutter, but you generate, how many chips are you cutting off that, that
it
tool.
pays for itself.
It pays for itself.
See, you got an array of coolant heads there to splash the tool constantly and keep it from not melting down.
Exactly. So these are all coolant lines that you can adjust and set to get cooling to the tool. This one right here is a computerized controlled one. So this one, depending on how long the tool is or where you want the blast of coolant, it will adjust.
Right.
This one right here is actually an air blast.
Oh,
so
okay.
This comes down, and if there's a chip stuck to the tool, like
Which
if
happens.
you're tapping or whatever, it'll just go and blast it, air blast, and knock that chip off, and then it can do the next hole or whatever. So
Fantastic.
yeah.
Love it.
Oh, yeah.
Had a little
Oh,
power
yeah.
feed set up, but it started taking a dump on me, and I'm just
Yeah, they don't last forever.
No, they don't.
I'll set this up, and you can just run this thing. It's going to be I can just set it up so you can push a button, and it'll just come down and mill a pattern or something, and then we can just keep stepping it down and
Walking in, shaving edge.
yeah, exactly. Yeah, this just seems kind of cool with the amount of things it can kind of do. Let's see, let's do...
Hit the flaking on the ways. So, you know, I still have my dad's hand flaking
Oh,
tools.
really?
Yeah.
That's pretty cool.
He used to be able to do that. He'd always try to teach me how to do it, but I couldn't keep a straight pattern. You know, so I noticed this one.
There's an art to that.
Yes, there is. He used
Serious
to do
art.
firewalls on Bugattis. The guys are doing
Oh, really?
restorations.
Wow.
I found one at the Imperial Museum in Las Vegas that he had done.
Dang.
I was doing a private tour with James Hetfield from Metallica, and I walk up on this Bugatti, and I'm like, holy shit, I remember this car, this firewall. My dad did that, and I was telling the tour guide, I said,
Wow.
my father hand flaked that tire wall.
That is cool.
At the time when he was doing it, he was one of like 2 guys still left on the West Coast that knew how to do that.
Wow.
It's an art.
That's very
an art.
artistic. Yeah. That's awesome. Wow.
Crazy stuff.
Okay, we set this thing up. Speed rate 3201. I think invalid value. Okay. 1, 2. Cool diameter. Ah. Okay. Cool. Cool data.
This Thanksgiving, the turducken goes. You're making chips.
Making chips. Yeah.
So you're making chips?
Yeah, making chips. That's what it's called.
What is a chip?
These are chips right here, and these
Didn't know we
generally
were being technical. What is a chip? What was that little shaving that just came
yeah
off?
the little shavings. Those are chips, and in this business those mean money. So we want to make those.
Unless it's titanium, then you're saving it and recycling it.
Right. Well, actually, everything we make, we recycle, or all the chips that we make, we recycle. We have these service that comes and picks up all the aluminum chips. We separate aluminum from stainless, and basically sell it back to the scrap guys, and they'll melt it down.
You're being environmentally responsible.
That's right.
That's important here in the Bay Area.
That's right. Yeah.
I think it's more economical.
Well, there's that too.
There's an economic factor.
There's always a correlation.
Yeah.
You know?
Yeah. Here, let me get some glasses, then we can crank that up and.
Sure. See, this is more or less what is like a manual machine, even though it's programmed and it's doing automatic stuff.
There you go. You want to be official? You can.
You
you
get
can
your
wear
own pair?
those. Yeah. And then for the shot, if you want to just let's dial this in 100,000. Hit start a couple times. It'll cycle through a program, and then it'll just cut for a bit. So. Yeah, there you go.
Right. Do the Jimi Hendrix, right?
Right.
Take a big lighter out, start a little fire.
Yeah, exactly.
Look at that.
Yeah, so what's so cool about this machine is that it's a standard, Bridgeport mill, which everyone is used to, but it has some CNC features that you can mill out a pocket really quickly and easily with just some simple conversational programming. It's to say, where do you want to drill a hole? How big is the pocket? Where's your zero? And you basically tell it those parameters and it'll cut it for you. So
now that's all manually input into this.
It's all
right?
manually input on this machine.
It's not like the other machines where you actually have like a, you do a CAD drawing, program it up CAD, and then put a disc in and press play.
No, it's not like that. On this machine, you get basically a drawing here, and you do all that by yourself, or no program. You just do it the old school way. You pick up a corner, you dial it in.
Dyke and blue, some layout lines.
There you go.
Stay inside the lines.
Yeah,
right?
exactly. Yeah, old school.
Yeah.
Well, what's nice is that in a shop like this, we have to rapidly prototype parts. Maybe it's not ready for production, but we want to try something out. So you know how this is. You'll come up, you make this little part really quick. You don't want to take the time to have maybe a full CAD draw up and program the machine, because you're making one little part just to try it out.
Yeah.
And this machine allows us to do that without upsetting any production. So.
Now, do you work a lot of times with the prototyping? Do you actually use like some of the other materials besides aluminum to just test and everything?
Yeah, we use sometimes some plastics like Delrins, UHMWs, ABS. Sometimes that works well for prototyping. Aluminum is great because it cuts well, it leaves a good finish, it's really structural. But yeah, there are some other materials. I've got some Delrin right here on the workbench that we're working with. So, but predominantly it's a lot of aluminum, a lot of stainless, steel, different grades of steel.
Yeah, I mean, ultimately, even if it's prototyping, still the finished product should be pretty much to what a production piece would be.
Exactly. Yeah. You don't want it too. We call it rough and ready, because you kind of lose some of the character of what you're trying to invent or create.
Sure.
So,
sure.
Yep.
Very cool.
Yeah.
Manual computer operated.
Yeah. Exactly. Yeah. Yeah.
It's just basically a really hard plastic.
It's a hard plastic. I mean, it has a lot of properties similar to aluminum almost.
Yeah, there's a lubricating property to Delrin as well.
There is, and this one especially, this is, I think it's the 13% PTFE impregnated Delrin. So,
what is PTF?
Teflon.
Okay.
Yeah. For anybody.
Not PTSD. But
No. Just Teflon.
Teflon.
But it does make this material pretty expensive. So we don't do too much prototyping unless really slick, low friction, plastic lightweight material is needed. We'll prototype with it, but
eventually it becomes a hockey puck.
Yeah, exactly. Yeah.
Very cool.
Yeah. So they buy this water jet part, and all we're doing is just tapping these holes. Super simple part. In fact, I'm going to have my daughter come in and bang those things out.
Run production, yeah.
Run production.
So
have you ever seen a flex arm?
No.
This is such a cool. This is a really cool tool. So I've got a second job set up here, but basically it's a tapping head.
Okay.
So
like the old Tapmatic.
I got one of those.
Yeah.
But
it drops down, it hits bottom, and it kicks out.
It kicks out. It's got a clutch. Yeah.
Yeah.
Let me reset this up, and we'll tap a couple parts. That would be good for the make a good show.
I get the feeling you're having fun with this.
Yeah, this is cool.
Right.
This is cool. All right, I got to move that thing now. No worries.
What's going on over here?
Well, he's going to set this up and show us a tapping procedure. Basically, this is it's a clutch tub, and he's going to put a tap arrangement in there. So when he drops it in to thread a hole, this thing will, like machine operation, it'll drop in, it'll bottom out, and it has a clutch, it'll kick free so that you don't destroy the thread when it bottoms out. Because everything's moving fast, right?
See that right there, exactly what you just did? That's completely new.
Yeah.
In the world of greatest state. So like that's exactly what I want. I want to continue with that. dialogue with
And I was thinking about this when we get over to the wheels and we talk about that. I'm going to probably like do a little intro maybe of it'll be in the world of moto culture, this is what moves you. Taglines, right? Moto culture, what moves you? You know? Yeah, what you missed with Saturday was they had on display down at the lab the modified one of these that I did for them for their display with the hubless wheel technology on it. They took to the engineering show. I had cut the swing arm back, lost all this stuff, painted it up in flat pearl white, and it still had some of the orange, but I lost all the turn signals, the big dorky mirrors. I streamlined it, made it look good. We pinstriped the rims. It makes up at 3 points. It's on a geared rim, and there's like a skateboard type wheel with a gear attached to the end of it that's driven by a little motor, electric servo motor, and that's what rotates the wheel. And because these are made up of 3 points with these skateboard wheels, if you will, it reduces. So in the world of ring drive technology, basically what separates this from the original idea of hubless wheels is that it's made up of 3 different points on a fixed.
No. I want you to look at my finger.
Oh, sorry about that.
Okay.
So in the world of ring drive technology, what separates it from hubless wheels is the fact that it's made up of, it's a fixed plate that has like what amounts to 3 skateboard wheels with a driven gear on the end of it, and the rim has a gear like a ring tooth attachment to it, and that rotates the whole assembly. The beautiful thing about it is compared to conventional wheel technology, where you have a centered axle and the wheel rotating around that, is that it reduces the heat signature on the wheel by roughly 30%. And for this company and the patents they hold with it, what it means is there is a lot of potential, say in military applications, you know, with the reduction of heat signature on the wheel, it makes it harder for, say, a heat-seeking missile to find a vehicle, you know, because it'll register whatever heat signature is coming off of the conventional wheel more easily. So there's a whole lot of different things that they can go into here with this, and that's what the licensing of the product's going to be about, you know, with all kinds of, you know, DoD, automotive, DoD meaning Department of Defense, you know, automotive industry, motorcycle industry. You know, you've heard the saying, the cliche about don't reinvent the wheel. Well, this is the perfect reason why you do reinvent the wheel, is you can always improve upon it. You know, it's like BASF used to say, we don't make the tape, we just make it better. So here you go.
Kevin,
we don't make the wheel, we just make it better.
Cut tap?
Yeah.
You want to go over there and direct Kurt on how to push the start button.
Okay.
So, I mean, you were basically...
I find this fascinating because, like, I didn't get a chance to get into CNC when I was younger. My dad had a manual machine shop, you know, so that's what I grew up on. But I just tell him, Scott, he said, man, I could hold tolerance all day long, you know, plus nothing, -2, whatever, as long as it's set up. But I don't know math, you know. It's like, I can make shit, but I can't make much, you know.
So is this, we just push start
Yes.
and it'll...
Push start, yeah, it's just gonna,
Cool.
but it should just come up and go out.
Okay.
Great.
All right.
Awesome.
All good, though.
Yeah.
And place yourself, do a little bit back over this way. Just
Okay.
the angle of it. That's perfect. Right there. Are you rolling?
And so I'm just explaining to Kurt what to do here. Is that the...
Kurt's going to talk about how we hammer.
Oh, okay.
Yeah. So I'll intro with the. So Scott, what I find so fascinating about this, like I mentioned before, you know, I grew up in a machine shop, but it was a manual machine shop. It was
Right.
pre-CNC days.
Yeah.
And for me, I find this really fascinating because it's just an extension of that, you know,
Yeah.
and just watching this stuff in action, for me, it's like, it's really just amazing.
Yeah,
It's just
yeah.
amazing.
Yeah, it is. It's a totally different feel, and it's pretty powerful when you hit that
Yeah.
start button. So you want to
Do I
give
get
it a
to
try?
hit the start button?
Yeah.
Oh,
Yeah.
fantastic.
Yeah.
Let me come on over this side. Jim.
Yeah. So right here, this is the control panel.
Right.
Everything's all programmed in. So at this point, when we're running a part, it's just production time. So you just hit and start, checking it after it's done for measuring and that kind of thing. But it's
Well,
all
I
yours.
know. I'll hit the green button, and if
Yeah.
anything goes crazy, hit the big red one
That's right.
and start. Oh, look at that.
You're making a part. Look at that.
Oh, the machine's making a part. I'm watching it.
Right.
Right. So isn't that what they call CNC machine operators now, right?
Yeah, it's a machine operator. Yeah. Yeah. Well, they're still machinists, but
Yeah.
it requires a machinist to do the setup, to do the running. But then at that point, it goes to a machine operator. So that's what you are today.
Right. Today I'm the machine operator.
That's right.
It's amazing how much coolant this stuff needs.
Oh, I know.
mean, they just flood it.
Yeah,
Just
yeah,
flood
it's
it.
complete flood. But I mean, you could reach in there and stop it right now, and that tool and that part is dead cold.
Right.
And you know, in the old days, that
Oh.
thing would be smoking and hot, and half of what you battle was the heat.
Yeah.
Now
Yeah.
with the coatings, the coolant, the rigidity of the machine, all those things.
Trust me, I know about the heat because I smoked a few tool bits back in my
Yeah,
time.
right.
I'd be running the speed too high, and
Yep.
I'd just like power it in.
Oh, yeah.
And you could feel it start to gum up and
Yep.
bind up a little
Yep.
bit. And it's like, I'm so close, I'm just gonna push it on through.
Yeah.
No, you just
Nah.
wasted a tool.
Yeah,
And probably the part in the process. You know?
Exactly. Well, that's the feel I'm talking about. You know, so when you can judge that and know that the current machinists, they need to know where those points are without actually feeling that. So
Right. That's sure taking a whole lot off the end of that block, isn't it?
oh yeah, yeah, that's a. I don't know if you can cut an inch deep on that thing, and
That's what it looks like, about an inch deep. Yeah.
Yeah,
Now, is that anything I can pick up in the language on this computer screen about depth of cut and anything?
Absolutely, yeah. The code it's reading it so quickly, it's hard
Right.
to pick out the line, but it's basically programmed to come down to the top of the machine, top of the tool, or the tool, the top of the part. It drops down half an inch, whatever it is, and then it makes the cut and steps over constantly, you know, until a desired point.
So X and Y
Yeah,
and Z,
And Z.
being depth.
correct. Yeah,
Understand it, X, Y, and Z.
yeah,
X, Y, Z, depth.
exactly. Yeah,
And there's the cut,
yeah. There's
finished
the
product. Cool to touch,
Yeah, yeah.
right?
Yeah, it'll be just cold.
Machine
Yeah.
surface finish, perfect.
Yep.
I mean, there's no final dressing. Maybe a deburr on
Maybe
the
a
edge
quick
by
deburr.
hand.
Yeah,
and-
exactly.
Or do you
Yeah.
even do that by hand anymore?
Well, you can do that in the machine. You call down a tool and it'll go around and cut an edge on
Right.
there, but just depending on the application.
Sure.
Yeah.
Sure.
Here's one of the tools I'm talking about. So it's an end mill is what it's called. This is in a tool holder, and the geometry of these flutes now is so amazing. They're called asymmetrical as well. So these two flutes might be closer together than the third one, and that is to reduce chatter and at real high speeds. The problem that you deal with is chatter and chip evacuation,
and
so
that'll create an uneven cut if it gets the chatter going on. You'll
Right.
get a wave in the finish.
exactly,
Yeah.
yeah. So they're playing with like harmonics and you know coatings and all these things, and it really comes out to a really high tech tool, and it doesn't look like much, but when you really dig into the geometry of it, it's just really amazing. So
Good stuff. Well, cool. There you have it. Basic CNC machining operation.
yeah, exactly, yeah. Well,
And I
done.
got to press the big green button.
yeah, and you didn't have to push
I
the
didn't.
big red one.
Yeah, thank God for that. You might not invite me back. Right? Yeah, Kirky's all right, but not welcome. Stay away from the machines. Right.
So you want to look at the tapping machine I've got?
Yes, please.
That thing's pretty awesome. Over this
Sounds
way.
great.
Yeah.
Okay, go. So
Guys,
look
you
at
ready?
it though.
All right.
I don't
The
remember
shatterproof glass doors are closed. And the light is flashing green. It means everything's ready, and I'm going to press play or cycle start. And now it just starts running code and inputting all the information through here. XYZ being the movements forward, backward, side to side, and depth. And it starts going through its motions.
We'll probably only use, yeah, that's good. We'll probably only use you pushing the button just because you guys were.
Sure.
So, Kirk, this is a horizontal boring machine, the big machine, and we have a job set up there, but we have a secondary machine set up on the same table, which is kind of portable. We can move it around wherever. And this machine is so cool because we can take a water jet cut part. This came from the water jet cut shop, just stainless steel plate. They cut in some holes. And you know, you can't tap on a water jet machine.
Yeah.
But we put this in here, and this machine right here is a tapping machine. And so I can just come over here, hit go, in and out, and I've got a tapped hole now.
Freshly clean. You don't even have to debird or anything, do you?
No, it's ready to go. So what's really cool about this is on a big production run, maybe in a mill we're just drilling the holes instead of taking the time in the mill to tap those, which we could. We could also have the operator on his downtime over here tapping the holes that the machine just made. So
this is the kind of stuff my father would put me on the weekends.
Exactly.
You know, working at the shop. It's like I put and take 100 parts, man. If it's got three holes to tap, you know, it's like,
Yep.
yeah, okay,
Yeah.
I'll give you 10 cents a hole. You know?
Exactly, yeah.
And I was off and running. It was buying me the next motorcycle part or model kit or
Right.
bicycle part. You know?
Oh, that's the best, yeah.
Yeah.
Well, it's funny, my daughter's coming in, she's home from college. She's coming in
Fantastic.
to tap about 300 holes. So.
Fantastic.
Yeah.
Yeah, right. Welcome home, honey. Get to
Yeah,
work.
welcome home, get to work. Yeah, get your glasses on, let's go.
Yeah, pay for that college education
That's
I just bought you.
Right.
Nice.
Yeah.
So, Kirk, granted your daughter's only going to make 10 cents a hole.
If that.
So, Kirk, do you want to do that?
Sure, I can
Yeah.
spot
So
a hole.
maybe Scott can show really
Yeah.
technical on how you're supposed to do it.
Okay.
Not, I'm just kidding. Imagine pushing a button.
Yeah, I was gonna say it's pretty basic.
So on the power down, that's driving. Which one? It's
This is power down, and then
that one's power
and
up.
then
Okay.
that's reverse.
Okay,
Yep.
got it.
Yep. Yeah, just put a dab of the oil
Little
on there.
will do ya?
Yeah, a little dab will do ya, and you're good to
Fantastic.
go.
That's awesome. You get set up over here.
Yeah, hold down this because it'll
Yeah,
want
we'll
to twist
start
that.
to grab it.
Yeah.
Okay, I think we're there. Now it doesn't want to come up.
Both.
Oh, both.
Both. Yeah.
No
yeah.
wonder you did it with such a fluid action.
know,
I was like,
you-
I was like, did he just let up on it there and then press with his thumb?
Yeah. No, it's all fluid. Yeah, you want to do it again to.
Sure.
Yeah. So yeah, you just hold it down and. Yeah, it's pretty slick.
Dexterity, man.
Exactly. Right.
Yeah, this
That's what
is
it's
like
all
playing
about.
with your iPhone, right?
Yeah. Yeah.
Okay, and center.
There it is.
There, I didn't screw it up.
No screw up.
Fantastic.
Yep, got a
Well,
good
if your
hole.
daughter doesn't come through, let me know. Maybe I can help.
Yeah, exactly.
It's like being a kid again.
Yeah.
See, greasy hands and
I
everything.
know, yeah. Feels good, right?
Right. Right. Until I wipe my nose.
Yeah.
It is. Yeah, that's cool. So freshly tapped part,
Yep.
and it is ready for installation on the machine,
It is, yeah.
whatever machine that may be.
Exactly, yeah. Yeah, sometimes you don't know.
Yeah, yeah, right. Sometimes I don't want to know.
Yeah, right.
This is top secret stuff. Fantastic.
Cool.
All right. What else we got?
I do
Welding
have,
procedures?
yeah, you want to do some welding? You got a bunch of that
Yeah.
down
we-
there, but
We can catch that on camera if you want.
Yeah,
I see
totally.
He's got the torch ready to go. He just
Yeah,
he wants to
he's
make
all
sure
ready
we're
to
not gonna
go.
Smoke him.
yeah.
Wait for people to not look.
Yeah, right.
Yeah, no one looked, but yeah, weld away. Yeah, go for it.
Yeah, you can just position your camera and catch him welding. Just don't look at the blue light. Whatever you do.
I think you're good through the camera.
Yeah.
Pretty impressive to me, anyways.
So what is this, Scott? What is that again?
This is the raw material blank for the Orbis rim, for the Type R.
Notice on the side it has the type of material and
Yep.
the heat treated rating.
Exactly, yeah, 6061 T6.
Yeah.
So this thing actually came out of a 10-inch thick plate.
Good
if you
Lord.
can imagine, 10-inch thick plate of aluminum, and then it was circle sawed with a large bandsaw.
I was wondering how they cored that.
Yeah, that's how they do it. So we buy it in like that, and then it makes it real simple for us to just put it right into the machine. We've got special fixturing and tooling to clamp this to a big fixture plate, and then we do all the turning operations. Flip it over, do the other side, and it's done. So,
Amazing.
and I've got one over in the other space that we can
Good.
look at. So
Yeah, would love to see it.
yeah. Should we head over there and
Sure.
check out? It's just a couple doors down.
That's how an Orbis wheel starts life.
That's
a
how it
cored
looks.
out blank.
Yep.
That's going to become a car wheel.
Yep.
I know it's kind of hard to see it now, but you'll
Yeah.
get it in a minute.
You'll have a car wheel and then a barrel of chips.
Right.
That's
Which
what
we
it's gonna turn
recycle.
into. Absolutely. Yeah. Cool. Let me go wash up and we'll go over to.
Sure.
Oh,
So Scott,
I think he's getting ready to run these. Is that the case?
Yeah, maybe like 15 or 20 minutes.
Okay.
That's cool.
Yeah.
We got plenty to, yeah.
No problem. We'll put a strap around it. 2 guys will hoist it up in there, but then we got an order for 20 of them. So we rigged a jib crane.
As long as I get to carve a sunroof in it, like Billy Idol.
Yeah.
All right.
you know what we could do is,
Bringing this to Kirk.
yeah, I mean,
okay.
Kirk's gonna say, all right, now we're over at
Cool.
Should Kirk explain what this is, and then you start going into the technical side of things?
Yeah, I can chime
Yeah.
in on
yeah,
stuff.
mean,
I
Kirk
can
could
do
say,
a-
over here, and here's a regular wheel. This is the one with the new
For those of you who
system. Of course, this does not have the motor, and then Scott can talk about how this works.
This will also give me that opportunity to intro in motoculture, you know, in reinventing the wheel, so to speak here. This is what actually moves you. We're going from your basic car wheel into the 21st century technology here with the Orbis ring drives. And Scott's going to explain to us the rest of it because I'm out of my depth there.
All right, so we're rolling. If you want to start, go ahead and whenever you're ready to start.
So in the world of motoculture, what we have here when we're looking at the concept of reinventing the wheel and all things that move you, what we're going from is your basic wheel with a center-driven axle into the 21st century with the Orbis ring drive technology, and this is the direction that we're taking this R7 here. And at that point, I'm going to turn it over to Scott because the rest to me is out of my depth.
Yeah. Well, it's a Type R.
Type
Sorry, not an
R.
R7.
Oh, did I say R7? Yeah, it's Japanese to me.
Yeah, right. Yeah, so like Kirk said and Marcus has explained, this in our wheel, the Orbis wheel, the hub is stationary and the rim rotates around the stationary hub, and that allows us to use a mechanical advantage for powering this wheel that's tremendous. So we can use a smaller motor, drive it off inner ring gear,
Right.
and have this huge mechanical advantage using that motor in its very effective, highly efficient state, rather than, you know, in a low efficiency, low power state. So,
And again, the concept that Marcus had demonstrated with the old-fashioned turntable was how much effort it takes to rotate the assembly from here
Yeah.
versus how much it takes to rotate it from there.
exactly. And so we're using all of that advantage by rotating the wheel off a ring gear at close to the perimeter of the wheel. So it's an easy spin up. So that motor doesn't have to work really hard. It's a quick spin up and super effective. So this is our prototype wheel. This is the first one that was on the car, and we used it for, you know, testing bearings, side load, braking, you know, all of those things before we actually put the motor into the wheel. So that's coming on the next generation that we're working on now.
So we'll see this at Burning Man soon, I'm sure.
Yeah, right. So like we just looked at in the shop with the blank, this is the rim that we made from that blank. So this gets a hard Teflon impregnated anodized coating. It's an aerospace coating that we have done on this for really low friction, very hard surface on it, and you get this, you know, really cool black color. So.
Anodized with a Teflon impregnated chemical additive to it.
Yeah,
Interesting.
yeah, exactly. Yeah, it fills up all the little porosity nooks and crannies of the material on a, you know, microscopic level. And
aluminum is notorious for
it's very
becoming
porous.
impregnated.
Yeah. And so with this coating, it fills in all those voids and gaps with the Teflon to make it more of a harder, solid surface. So
makes sense.
yeah.
Very cool.
Yep, so this will go up on the car and we'll do some more testing with this, and soon we'll have the motor in the wheel and be able to do some power testing.
So Scott, if you can talk about, I think you guys are using a military drone motor at 10,000 RPM.
Yeah, on the scooter, that's what we've used.
Okay.
This is going to be we're using Zero motorcycle electric motor systems.
Okay, so if you can go back down and say,
Okay.
What I'd like to see is, you know, what the other side of this looks like.
Mm-hmm.
Okay, what the other side of that looks like, and then is that damage that we want to look at?
This is all about prototyping.
Oh, so it was cut away?
Yeah.
Okay.
Yeah.
But, so talk about maybe where the motor goes.
Yeah.
You know, even though we don't have the motor, where the motor's going to go, because I know he's going to send us a video on your how it all goes together.
Got
but
it.
If you
Yeah.
can say this is where the motors go, this is where the motor goes, and this motor drives, and it turns this.
Yeah.
Okay.
Yeah. So this is the inside of the wheel. You can see some milling we had to do to because this is a retrofit. We're retrofitting this to existing equipment, so we had to do some interesting milling to make everything all fit for the prototype run. But basically, when we go to motorize this, the motor will take up all the space here in the center. This all changes, and we use different mounting pickup points for the suspension. That allows us to remove this whole center section, and that is where the motor sits, basically in this section here. And then the shaft will run a pinion gear out to this place holder right here, which will be the ring gear.
Very interesting. So the motor sets up there.
Yeah.
And it drives the rest of it. This is stationary, and it just
This is
spins
stationary,
it,
and it will spin. The shaft will be down to the bottom and spin on a pinion gear that'll be down here and onto this this aluminum ring, which will be a gear as well. So right off the brake disc.
Go ahead and just show how the thing turns.
Yeah, this would be stationary, so you'd have to, you know.
Okay.
You'd hold this up and
the
go ahead
wheel
and spin
spins.
that thing, and that's what it'll look like.
Look at that free spin.
Yeah. Yeah, very low friction. Yeah, it'll just go
It
and
just
go.
keeps going.
Yeah.
Like I've seen the ceramic coated bearings and stuff, and how I've done like the little Oki test, you know. It's like, here's a stock sealed bearing, spin it, and it gets
Right.
about 1/3 of a rotation before it stops on
Yeah.
its own accord.
Right.
And then I've taken the ceramic one on my finger and spun it, and a minute and a half later it's still
Right.
spinning. It's
Yeah.
like, that's incredible.
It really is.
Very
yeah.
expensive bearings.
Yeah.
You know,
Yeah.
they use them in MotoGP.
Right.
You know, I mean, every little extra counts.
Every
Yeah.
percent counts. Yeah.
Yeah.
Exactly.
And the quest for horsepower and who's
Yeah.
first to the finish line.
That's right. Yeah. Yeah.
It's amazing stuff.
It is.
Yeah, the future of what moves you.
On this design. So the motor's actually here. There's a power assist. So this is a human-powered version with electric power assist. It goes through a normal bicycle chain drive to a secondary gear that increases the pinion speed, because on this huge wheel you need massive pinion speed. So and then it drives on this gear on this ring drive here. So
How fast does it go?
like a typical bike, it rides like a beach cruiser. You know, it's not a speed racer, but again, this was a quick down and dirty prototype we threw together to see.
So the goal wasn't necessarily to achieve any greater performance, say over manual man-operated. It was just to be proof of technology.
This is a proof of concept vehicle. Yeah,
right.
Exactly.
An expensive bike.
Yes. Yeah.
A very expensive bicycle.
Expensive bicycle. Yeah.
So
Is this some kind of a quick release? What's that? It's just tension, that roller?
Yeah, that's just the adjustment for
Okay.
the tension on this roller. So we have much more elegant ways to do that now.
All right,
But
all right.
but on this, we were looking for as many off-the-shelf parts and prototype it real quickly. Like I was talking about with the little mill over there. Everything on this bike was made on the prototype mill. Just really quick, make a block, put a hole in it, cut a radius. Put a couple holes in this. It's all rough and ready type prototyping.
It's a lot of effort to satisfy an investor.
It is. Well, and the last minute thing was this contraption here, which doesn't look like much, but this actually holds a beer case or keg or something perfectly. So
I was going to ask. I was
for.
getting there. I was like, okay, so you guys cut up a regular bicycle wheel rim and attached that there. Why?
Yeah. Well, for beer.
Just for beer.
Yeah.
This
that's all
is
that was
clearly not enough beer.
for. There's not enough beer here, so we had to add the
And the
secondary
lower
storage.
center of gravity
That's
makes
right.
it easier to not
right.
fall over.
Exactly,
When you've
yeah.
had too much beer.
That's right.
Which maybe that's your fail-safe, right? If you can't keep it stable after you've consumed a few,
That's right.
time to stop. Right? Call Uber. That's funny.
They're just going to get some B-roll and film you while you're working away. No pressure. Don't.
His starting roll is pushing buttons.
That's right. Yeah. This is, as far as I know, this is typically when the machines crash. It's when the video camera's on, Now,
Oh,
so
it's-
what
yeah, it's
Marcus
way
wanted them to do, they're like, yeah, we want to start fresh. And so they talked Marcus into starting fresh with Lotus. Have you seen the Lotus?
No.
Super 7 replica?
Okay.
Yeah, like a little open-wheeled cockpit
antique
little
ones,
car.
yeah.
Yeah.
So whatever's got the closest dimensions.
Yeah, that is probably pretty close. So I think that body's going on that car at some point.
All right.
So.
But he's kind of a interesting and unusual, guy that wants to experiment with stuff too. Like I got a 66 or 7 MG, and he says, I've been toying with making it all electric, and I'm like,
Well, there you go.
this is the perfect opportunity
Right.
then. And I told Marcus about that, and then all of a sudden Moles popped up and says, now we're going to Moles.
Yeah.
All right. Somebody pushed it that direction.
Yeah.
Because I don't think he got there on his own.
Right. Yeah. Yeah.
Whatever.
Yeah. And that stuff changes so often.
Yeah, and I tried to pick up about
sorry.
this.
Sorry, you're all excited.
Yeah. Which would have made it actually easier in a lot of ways because mistaking one
I'm
machine
kinda-
for another.
If you wait until it cycles off, it'll probably stay off for a little while.
I'm.
Even the old
Sure.
60s school
I
desk.
the hammer
kind
started
of
to
siliconed
take
in
off.
my depth
Right.
check.
That's about the best I can
The
do.
perimeter.
21 minutes for
they're
side
using
one. That's the
5/16.
run time. It says 21
These
minutes.
four.
side-
Does that help?
Yeah, that might help.
Yeah, I mean, you could look at, just go stand back, put your backs against that, kind of, and then you just could talk about, those are the
Right.
the slugs. Here's the machine. This is Kirk's big moment. He gets to push the start button, and it's going to take roughly 40. You don't have to talk about how long. It's going to take a while, and this is kind of what it's going to end up looking like.
Cool.
It's going to be short and sweet because there's not a lot to talk about.
Yeah.
So whenever you're ready.
Okay.
Rolling.
All right, so what we have here is the blank that will eventually be machined into this, and this is not a finished piece, but that give you an idea of how much material is going to come off of that blank. And this is the turning center that performs all those operations.
Right.
So Scott, tell us a little bit about it.
Yeah, like you said, that's kind of the rough step. This is the pre-machining, and that's what we're set up to do here. So the machine's all set up, it program's in there, it's all running, ready to hit the green button. So if you want to do the honors, and
Man, I get to press the green button again?
Yeah, let's get this thing going.
Look at that.
Yeah, there it goes, just ripping away chips. Beautiful sound, right?
Yeah,
just
that's
humming.
the sound of money.
That's right. Yeah, you can hear the chips hitting the back shield, and you know that's it's a good sound.
That's right.
So, yeah, it's just cruising along in there. So that machine will just keep cut and pass. It's going about a 400 thousandths deep, almost half an inch deep.
That's a lot
as
of
it's cutting
material.
across, yeah, on a diameter. Yeah. So it's just ripping it off, and as you can see, it's got a lot to go. So it's going to keep turning, turning down and down and down until it gets to this point.
So what's the benefit of this being a solid piece versus, say, something that, like a piece of plate that might be welded or, or
Well, that's always an option, but when you do that, you have two interfacing surfaces. They have to be machined, drilled, and tapped. There's a lot of labor in that. With the modern machines, they can rip material away so fast. It's more effective usually to start with a big slug and just mill the stuff away or turn it away. Yeah, it's. I mean, that might take, I don't know, 10, 15 minutes to mill that down. Whereas to make two separate pieces, drill and tap holes and all that, it's more cost effective to do it this way.
So, something I've been noticing in our conversations is like, you're definitely passionate about this.
Oh yeah.
What was it that got you involved? I mean, what made you want to do this?
Yeah.
What moves you?
Yeah. Well, it's probably similar to your story. I was a little kid, and I remember driving with my dad, and we're at a stoplight, and there's a truck in front of us, and there's a trailer hitch, and there's a trailer hitch assembly has, some machine parts, some fabricated parts. And I remember the first time noticing, like, what is that thing? And my dad said, oh, that's a trailer hitch. That's pulls the trailer, bolted to the chassis. I thought, well, how to get there? Like, someone had to make that. Someone had to design, cut those tubes, weld them together, and it opened my eyes at a really young age that, oh, that's like my Lego set. Like, I can create something and build something.
Right.
And so from a young age, I knew there's something inside me that wants to build and create. Take raw material and build something out of it. And so that's kind of the path that I've taken. So I did a welding apprenticeship at a food and chemical industry component maker, and got fabrication skills. I then went to another shop that put me through an apprenticeship for machining. And so I have the fab side and the machining side, and those conceptual ideas, and really it's just a lot of street smarts. I don't have a lot of formal training as far as design or engineering, but I kind of know what works and what doesn't work.
So how did the Orbis wheel thing come about with your relationship with Marcus and everything? I mean, that's a big step from a production machine shop.
Huge, yeah. So I was just starting up my my side business, doing my own kind of design, customizing, machining firm on the side, and met up with Marcus at a networking event, and he had a bicycle background, I have a bicycle background, and so we kind of hit it off. We spoke the same language.
Right.
And so through a couple different little projects, he said, at one point, he said, what I really want to build, what would really solve my problems is like a spokeless wheel or a stationary hub wheel. And I said, okay, well, I'll bang it out. So I made a rough and ready quick prototype, and from then on, we kind of worked together and built this thing from bicycle applications, wheelchairs, you know, motorcycles, cars, you know, whatever. So now we're deep into it, and we're, you know.
Oh, it definitely looks like you're getting some traction with it.
Yeah.
I mean, you know, the response that I heard about from that engineering show just was phenomenal.
Yeah.
You know, and it's like a whole bunch of new doors are opening for you guys.
Yeah.
Really, the sky's the limit.
Yeah, it really, I mean, it can go so big. I mean, the whole, you know, reinvent the wheel thing,
Yeah.
I know it's so tired, but in this case, it really is true. So, you know, to answer your question, I was just kind of a guy that can make parts looking for something to really dig into, and Marcus was a guy with some ideas, and, you know, we kind of met together, and now it's just exploding. So
That's fabulous.
yeah,
That's
it's
great.
pretty exciting.
I love it when it's kind of like one of those things. It's like in the universe where they just come together.
Yeah.
You know, it's like, oh, this is like
Yeah.
it was meant to be.
Yeah,
you
perfect
know?
alignment. Yeah,
Yep, perfect alignment, the stars and everything.
yeah,
Right.
yeah, yeah,
Fantastic.
yeah.
Well, look at how much material that's taken off already.
Oh yeah, yeah. It's
Jeez, it's a
cruising
couple
down.
inches in.
yeah.
That's crazy. If I was trying to do this on a manual machine,
Oh,
I'd be there
man.
for days.
Oh yeah,
You
yeah.
know?
This is about a
30,000, 50,000
Yeah.
paths.
yeah. This is about a 2 to 3 day solid manual part. I mean, probably 20 to 30 hours to make one
Wow.
manually, and we're getting these down to, you know, probably 3-4 hours, something like that, to, you know, from start to finish. There's some mill operations, and so it's a pretty complex part. It holds some really tight tolerance bearings, tight tolerance seals.
Yeah.
and so
Yeah. No, I get it. There's a lot of really precision made pieces to go into this whole finished product,
yeah,
you know?
yeah, yep.
Love it.
Yeah, fun stuff.
Yeah.
Yeah.
Well, cool.
Yeah.
Thanks for showing us everything, man. Really
Oh, yeah.
appreciate
Yeah, it's awesome.
you know, the opportunity to bring people in to see this.
Oh yeah.
You know,
Yeah.
stay tuned. You'll see it on your cars soon enough.
That's right. Soon enough. Yeah, exactly. Cool.
Right on.
Whoa. All right. Here we go.
Don't break it. Hit
Little
the red
awkward,
button.
awkward hug there.
Alright, so we got some plate stuff.
Okay.
Got the American flag in the background.
There
Oh,
we go.
perfect. Yeah. Yeah.
You want to do
Is that balanced?
Yeah, I'll do a two-shot. I mean, I'm doing a two-shot if you want to do a two-shot. Or you want to do a close-up, what do you want to do?
Maybe one two-shot, one close over the shoulder type of thing.
Do you want to do curve over the shoulder?
Well, I'll do, yeah, I'll do like,
And I'll do a two-shot.
okay. Yeah, this looks good.
Yeah, don't trip over the pallet
I
jack
know.
there.
Hey, I've been injured. I'm used to this.
Yeah, I bet. I
Oh,
bet.
yeah. He does
Oh, man.
firefighting.
Oh,
and
wow.
he blew his knee out playing basketball.
No,
Dang.
the Achilles. Twice.
Oh.
Achilles, right,
Oh.
right.
And a
Ruptured
pulmonary embolism.
Oh.
All right, so whenever you guys are ready.
Okay.
So, Kirk, hold on. Just want you to take your time.
Yeah.
Just do a little breath and then wrap it up. So whenever you're ready, we're rolling.
I have found my center. So Scott, I wanted to say thank you for letting us into your world here and showing us, you know, the Orbis project. You know, it's some very exciting stuff,
Yeah.
and I feel honored to get a walkthrough here and a little hands-on with
Yeah,
it.
yeah.
You know, I think what you and Marcus are doing is awesome, and I really look forward to seeing it in the future. So
Awesome.
thanks
Yeah.
again, my friend.
Yeah, thanks a lot, Kurt.
Much appreciated.
All right, man.
You
Take
guys
care.
are great. Yeah.
Take care.
The more the awkward. Come on, man, give me a big old hug. Don't worry, man, it's not gay. And it's cool if it is. You know? No sword fighting in this episode, right? Just for
no.
the record.
Yeah, that's right. That's right.
So yeah, that's good. Let's try another one. Maybe
Okay.
I don't know if we need to talk about the show
Or sword fighting.
or sword fighting. Yeah, I'm still rolling.
Maybe do something more towards us, like, all right, we're gonna wrap it up here and let these guys get back to work. Thanks for showing us around, that type of thing.
Yeah,
Yeah.
thanks for spending time with us. Thanks to you and Marcus for taking time out of your day. You know, kind of wing it.
Sure, sure.
I don't know if we need to talk about being on the show. But we don't know what the show is, but you know, thanks for opening up your world to us. Blah 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 blah.
Okay.
Talk to the camera guys.
Okay.
But I still want you guys engaged, conversational.
Yeah.
Okay.
You know, that you guys are part of a conversation.
Okay.
So we're rolling whenever you guys are ready.
All right.
So I think we're going to wrap it up here today, and I wanted to thank you, Scott, for letting us into your world, the Orbis world.
Yeah.
You know,
Yeah.
the Orbis wheel technology is just amazing. I see a lot of interesting stuff coming forward here from you guys. So,
Yeah.
you know, again, thanks for letting us
Yeah.
be part of this, man, and
Yeah.
letting our viewers into this world.
Yeah, yeah,
You
you
know,
bet.
it's great stuff.
Anytime. Good to see you, man.
All right, brother.
All right, I got to get
Stay
back
well.
to work.
Yep. Cheers.
All right, I got an idea. I want something like this.
Another one.
We have something to cut to.
All right, so we're pretty much done here over at Orbis Wheels. We're going to wrap it up and get out of here, get out of Scott's hair, let him get back to work making some of these beautiful projects. Scott, I want to thank you so much for letting us into the Orbis world, man.
bet.
There's some
Yeah.
great things coming from here, and I look forward to seeing more. Bless
Cool.
you. Thanks,
Thanks a lot, man.
All right.
Back to work.
Chasing you around.
All right, one more. And then we'll wrap it. All right. We're still rolling.
God bless America.
How you came at us with that, like,
Huh?
I like how
Like
you,
that?
Yeah, I like how you were
Okay.
interacting with us, the audience.
So we're going to wrap it up here at Orbis Wheels in the manufacturing facility run by Scott, and you know, let him get back to work. This guy's got to make a living, and all we're doing is getting in his way. So again, Scott, thank you so much for
You bet.
everything, man.
Yeah.
It's been great hanging out here with you today, and I look forward to seeing more from you guys.
Thanks a lot. Appreciate
Cheers.
it. All right, back
All
to
right.
work.
Then break into God bless America.
It's not like out here, like in Westchester, dude. They pull them over and they go, "Oh, it's you here. You know what? We'll get you home safe.
There, they
You're
don't
too
give a
drunk,
fuck who
whatever
you are."
Here they don't give a fuck who you are, but they want like autographs from them out there and shit. Right. You come out to California, man, you're going to jail for that shit. Yeah, right here, sir.
So he did react. He's all through that.
They
Or?
did this chemical balance test on he had, like, he's basically used it all up with all the shit he's done in his life.
It doesn't remanufacture. You get X amount, and
I
that's
think
it.
you only have so much, and like certain people have more than others. You know, like certain people fall into depression easier than other people. You know, like I never fucking. It's hard for you to understand because I'm.
Hey, how are you?
I'm good. I'm fine. You guys get everything you need for.
You never get enough. No, but bikes are cool.
Yeah.
All the stuff you guys are doing is